Good afternoon, everybody. Just let me know if you all can hear me, please. All right, cool. I know people wanted to know what I'm going to be doing today. It's going to be several different things that I'm going to try to cover, right? Because this may be my last session, right? If I do have time, I will try to have some impromptu lives, right? But I'll see what I can cover today, all right? All right, what's the time? 2:58. Okay, I might as well start, right? Let's see, where am I? Give me a sec. All right. So CXE indicated that you all will be getting a functions question, right? So you all need to be able to handle a functions question. So let's look at these questions here, right? These are all exam type questions, right? They're past papers, can't remember what year they are. So we have two functions here. We have function g and we have a function f, right? And the first part, they said state the value of for which f of x is undefined, right? State the value of x for which f of x is undefined. Now, in order to be able to answer this question, there's something that you all need to know. If I have a number, right, and I divide that number by 0, I'm going to get 0. Sorry, I'm going to give you the other way around first. Sorry about that, right? Hold on. If I have 0 divided by any number, I'm going to get 0, right? But if I have a number divided by 0, this is undefined, right? So in maths, you can use a calculator. If you use a calculator and you take, let's say, 5 divided by 0, the calculator is going to spit out an error for you, right? So we are looking at the function f of x here, which is this guy here, right? And they said state the value of x for which the function f of x is undefined, right? Now, undefined, right? To make a function undefined, my denominator here has to be 0, which means you see this x plus 1 here? You need to put that equal to 0 and solve for x, right? So what you're going to do, so this is part 1 here I'm working out, right? You're going to say x plus 1 is equal to 0, therefore x is equal to minus 1. So what you're really trying to do is find the value of x such that when I plug it into the denominator, right, I'm going to get 0. So the only way that will happen is if this x here is minus 1. So minus 1 plus 1 will give me 0. So therefore the value of x for which the function is undefined is minus 1. That's my answer there, right? So they bring this particular question ever so often. So please make sure you know how to do this, right? Let's look at the next one here. So in part 2 now, they want us to find g f of 5, right? This is what we call a composite function, right? So you want to find g f of 5. So here's what you're going to do. I need more space to work this question, right? Hold on. So these are my two functions here, right? And you want to find g f of 5. So here's what you want to find. You want to find g f of 5, right? That's what you want to find. Now, g f of 5, right? So here's what you need to do. This is what we call a composite function, right? And let me use a different color to show you how we work this out. The first thing you guys need to do, you need to figure out what is f of 5, right? And then when you get an answer, you're going to take that answer and you're going to plug it into the function g. So this is a two-step process that we have to do here, right? You're going to find f of 5 first, and then you're going to take that answer and plug it into the function g. So let's see how we're going to do that. So step 1, I'm going to find f of 5, right? This here is my function f of x. So all I'm going to do, I'm going to make a substitution. I'm going to substitute x equal to 5 into that function. So this is going to be 2 multiplied by 5 plus 7, right, divided by 5 plus 1, right? So all I'm doing, I'm substituting 5 into my expression. That's all I'm doing, right? Now, just by the look of it, you're going to get a funny fraction, right? So 2 by 5 is going to give me 10 plus 7 divided by 6. And that's going to give me 17 over 6, right? So that's step 1. This is what we're trying to work out. We're trying to work out this gf of 5. Now I'm going to take that answer that I just got now, and I'm going to plug that into the function g. So what you're going to do, you're going to say g, you're taking this answer here, right? And you're going to plug it into this. So this is 17 over 6, right? And I'm going to plug that into this function here. This is my function g. So it's going to be 4 multiplied by 17 over 6, right? Plus 3, right? So that's what I'm going to do here. Now, you all should be comfortable, right? Whatever calculator that you're using, please be comfortable substituting numbers in your calculator, right? Now, I like to show my students how to use their calculator, because there are students who there are problems just to work out something simple like this. So here's what you need to do. You want to work out 4 multiplied by 17 over 6. So I'm going to press 4 multiplied by 17. This calculator can work out fractions. So you press this AB/C. So that's 17 over 6. And I'm going to get this answer here. That answer that the calculator is giving me here is 11 and 1/3, right? And then I'm going to add that to 3. And I'm going to get this answer here, 14 and 1/3, right? Now you can leave your answer as that. You can leave your answer as 14 and 1/3, or the calculator fancy enough to give you an answer as an improper fraction, right? So all you need to do here is just press this second function and the same fraction key here, and you're going to get 43 over 3, right? So this here is 43 over 3, right? Now you all have exams right around the corner, right? So these are things you should know already, right guys? All right, so that's the answer. So the question asks us g f of 5, so then you're going to tell them, therefore g f of 5, right, is equal to 43 over 3. Right? Or you can leave your answer as 14 and 1/3. It doesn't matter. Right? So that's my answer for part 2 in this question here. gf of 5. The next thing they want us to work out is f inverse. Right? So this here, they want you to figure out what is the inverse of a function. Right? That's what they want you to find. The inverse of a function. Now this particular question is the hardest inverse they can give you in the exam. Right? So let's write that. So we have f of x is equal to, what it is, 2x plus 7. So this is 2x plus 7 divided by x plus 1. X plus 1. And the question wants us to work out f inverse of x, right? Now, like I said, this is the hardest inverse function they can give you in the exam, right? Because there's some factorization that you're going to have to do. Now, there are certain steps that we need to do in order to find the inverse of a function. Your first step is to let y equal to 2x plus 7, right, over x plus 1. The next step is to interchange x and y. So that's my step 2. Interchange x and y. Now, what that really means is that anywhere you see x, you're going to put y, and anywhere you see y, you're going to put x. So therefore, I'm going to write this as x is equal to 2y plus 7 over y plus 1, right? So this is step 1. You let y equal to that. This is step 2. You need to interchange x and y. And then the third step is to make y the subject of the formula, right? So my third step is to make y the subject, right? That's what you're going to do. So we're going to do that. So I'm going to put, now you see this expression here, right? What I typically tell students to do is to write this as x over 1 is equal to 2y plus 7 over y plus 1, right? The reason why I'm doing that is because I'm going to cross multiply in order to help me to make y the subject of the formula. So if I cross multiply, I'm going to say x by this is equal to this by this, right? So I'm going to end up with 2y plus 7 is equal to x multiplied by y plus 1, right? So then we're going to have 2y plus 7 is equal to, you need to remove your brackets. So it's x by y, which is going to give me xy, and then x by plus 1, and that's going to give me x, right? Now the objective is to make y the subject of the formula. So this is going to be 2y minus xy, right, is equal to x minus 7. Next thing you have to do here, you realize you have two terms in y on the left hand side. So you're going to have to factorize. So this is going to be y, open brackets, 2 minus x is equal to x minus 7. So therefore y is equal to x minus 7 over 2 minus x. So therefore, the final statement that you need to write is this. My inverse of that function here is simply going to be x minus 7 over 2 minus x, right? That's going to be my inverse of my function. Now, one thing I want you all to remember, sometimes, depending on how you rearrange the equation, you can get an answer that is slightly different, right? And it depends on how you rearrange the equation, right? So sometimes, so let's say somebody could have gotten an answer that looks like this, right? They would have gotten an answer that looks like this, 7 minus x over x minus 2. Right? This is an alternative answer that students can get for the answer, and both of these are correct, right? Both of them are correct. So keep that in mind. Whenever you have a function looking like this, there are two possible answers, right? Both of them are correct. So let's see what else we have here. So we have two more, right? I want to try to cover as much different kinds of questions that we can do, right? Hold on, let me just get this on a separate page here. Like I said, all of these are exam questions, right? So the first part 1, it's a composite function you want to find. You want to find fg of 2. So just like in the previous question, what we're going to do, we need to find g of 2 first, and then that answer, you're going to plug it into this function here. Right? So g of 2, right? You're going to take that and plug it into this function here. So this is going to be 4 multiplied by 2 plus 5, right? Which is 4 2s are 8 plus 5, which is 13, right? So that's g of 2. When I get that answer now, I need to take that 13 and I need to plug it into the function x. So what I'm going to do, I'm going to find f of 13, right? So I'm taking the number 13 now and I'm going to plug it into this function here. So that is 30, that is 2 multiplied by 13, right, plus 1 all over 3. So that is 13 by 2 is 26 plus 1 over 3, which is 27 over 3, which is 9. So therefore, my answer, which is fg of 2, is equal to 9, right? So when you have a composite function, right, that's what we do. We do it in two parts, right? Now, CSEC indicated in the broad topics that this is coming, right? So make sure you know how to do a question like this. Now, there are some students, what they do sometimes, they go and they work out this. They work out fg of x first, right? Which you can do, right? But this method that I'm showing you here is much easier. Now, here's what the next part of the question is. So the next part, right, you want to work out this here. F inverse of 3, right? F inverse of 3. Before you can work that out, you need to figure out what is the inverse of f first of all. So the function we have for f is this, 2x plus 1 over 3. So your first step was to let y equal to 2x plus 1 divided by 3. That's my first step. Your second step is to interchange, right? I'm not going to write down the words here, but we're going to interchange. X is equal to 2y plus 1 over 3, right? And your next step is to make y the subject. So I'm going to write this x as x over 1, and then I'm going to cross multiply. So this is going to give me 2y plus 1 is equal to x by 3 is going to give me 3x. And therefore 2y is equal to 3x minus 1, right? So therefore y is equal to 3x minus 1 divided by 2. So therefore my inverse function f inverse of x is equal to 3x minus 1 divided by 2. That's my inverse function. But the question says, here what? I need you all to work out f inverse of 3. So all we need to do to work that out is to take 3 and plug it into this equation here we have. So this is going to be 3 multiplied by 3 minus 1 all over 2. So this is 3 3s are 9 minus 1 over 2. 3 3s are 9, 9 minus 1 is 8. 8 over 2, that's going to give me 4. So that's my answer there, right? Right? Now, I know a lot of you all were asking me about to do a video on circle geometry, right? Because you're all getting that in the exam. But if you all go through on my channel, right, I have a video on several past papers on circle geometry. So have a look at that, right? I've gone through probably about 5-6 years past papers on circle geometry there. Just go through that and you're going to be okay, right? All right, now I'm going to switch gear a little bit, right? Because I want to be able to do as much questions as I can, right, in this session, right? And when I say questions, I mean different types of questions, right? So I'll come back to this if I have a little more time, right? But those are the questions you need to know how to answer. Now, let's look at this question here, right? This is on straight lines here. Write down the slope of this line, y is equal to minus 4x plus 7. Right? What is the slope of this line? Now, when it comes to a straight line, you all need to know that the general equation is y is equal to mx plus c, where m is my gradient, right? And c is what we call my y-intercept, right? So m is my gradient, c is my y-intercept. Now that equation is written in the format y is equal to mx plus c already. So therefore, if I wanted to write down the slope, and by the way, another name for slope is also my gradient. So don't get confused when you go in the exam and they say slope, and you'll be like, I don't know what slope is. Slope is gradient, right? That's just another name for it. So y is equal to minus 4x plus 7. That means that the slope of this line here, right, is equal to minus 4. How do I know that? It's a number just in front of the x. My slope is minus 4, right? Somebody asks if you can put a function into another function. Yes, you can do that, right? Not all students know how to do that properly, and that can be a problem, right? Now, this next part here, they want us to write down an equation of a line which is parallel to this line, right? Can you all tell me what the answer is for part 2? All right, so somebody said any equation that has a gradient of 2. That's correct. That is correct. So here's what you need to do. So this is part 2, right? They said they want you to write down the equation of a line parallel to y is equal to 2x plus 3. So y is equal to 2x plus 3, right? That means that this gradient here, right, is equal to 2. Now, parallel lines, that's something you all need to know. Parallel lines have the same gradient, right? So parallel lines have the same gradient, right? So therefore, any line that is parallel to this line should have a gradient of 2. So therefore, y is equal to 2x, right? And they said they want you to write down the equation of a line parallel to this. So I could put any number here. I could put 5. I could put y is equal to 2x minus 4. All of those lines are parallel. All you need to do is to change the c, and that's it. That's all you need to do, right? So the equation of a line parallel to y is equal to 2x plus 3 will be y equal to 2x plus any number, right? So that's my answer for part 2. The third part now, write down the coordinates of a point where the graph crosses the y-axis. Now these are questions that you can be given in the exam, right? So part 3. Now, whenever a straight line crosses my x-axis, these are some things that you need to know. On a graph, right, this here is your y-axis, this is your x-axis. But those axes, they have an equation. Your x-axis is also the line y is equal to 0. That's what my x-axis is. My y-axis is also the line x is equal to 0, right? And if you ever want to figure out where a line cuts your axes, these are the numbers that you're going to substitute in order to figure that out. So for example, they want to know where does the graph cut the y-axis. Now, you already have this equation in the form y is equal to mx plus c. The point at which a line cuts the y-axis is called my y-intercept, right? Now remember, this here is my general equation for a straight line, and c is my y-intercept. So therefore, this line here, y is equal to 6x minus 5, is going to cut at the point 0 minus 5, right? That is where I'm going to cut my x-axis. That's my y-intercept, right? 0 minus 5, right? So there's nothing to calculate there, right? You just have to look at the equation, and from the equation, you can tell what the y-intercept is. Part 4, they said the point K7 lies on this line, find the value of K. So here's how you do something like that. Y is equal to 4x minus 3, right? And you know that the point that lies on the line is K7. Now what that means is that when, remember this is a coordinate they've given us here, this is a coordinate. So when x is equal to k, y is equal to 7, right? That's what this coordinate here is telling me, right? Now if I plug x is equal to k into my equation of the line, right, I should get 7 as my answer. So I'm going to substitute this and I'm going to substitute this into the equation of the line that they gave us. So this is going to be 7 is equal to 4 multiplied by x, but x is k, minus 3. So I can write this as 4k minus 3 is equal to 7. So 4k is equal to 7 plus 3. So 4k is equal to 10, right? And remember the whole point here is to work out what is k, right? We're trying to work out what is k. Now I realize my video will block you here, so hold on. Huh? So I'm going to write it in corner here. So k is simply going to be equal to 10 divided by 4, right? Which is 5 over 2, right? Or 2.5. That's the value for k. Now these are possible things you can get in the exam, right? These are possible things you can get in the exam, right? Now, like I said, I want to give you all a range of questions that you could potentially get, right? So let's look at another question here. So sometimes CSEC can ask you to draw a quadratic graph in the exam, right? They can't do that, right? They're not going to ask you, in order to plot a quadratic graph, it's going to be a curve. And in order to plot a curve, we need several points, right? If you just have to draw a straight line, all you need are 2 points in order to draw a straight line. But a curve, you need several points in order to do that. And typically, CSEC will give you a table that you need to complete, right? Now, we need to complete this table here. We need to figure out this value, right? And 4 more values. So here's what you're going to do. You know that y is equal to x squared minus x minus 5. Right? So to get the first value, I need to substitute minus 2 into my equation. So what I'm going to do, I'm going to substitute minus 2 into this equation. So this is going to be minus 2 squared minus 2 minus 5. Now you see questions like these, students have trouble with this, especially with minus signs, right? So let's do it step by step. Minus 2 squared is going to give me positive 4, right? Minus 2 is the same as saying plus 2 minus 5. So therefore that is 4 into 6 minus 5, and that's going to give me 1. So this first value here is 1, right? If you all want, you can double check with your calculator, right? Let's make sure we get the same answer. Next thing I have a mistake, right? So I know you all have exam next week, what, Wednesday, right? So that time is going to come really quickly. So the next value I need to figure out this value in the table here. So that means I need to substitute 0 into my equation. So you write back the equation again. Y is equal to x squared minus x minus 5. And then we're going to substitute 0. So this is 0 squared minus 0 minus 5. Right? So 0 minus 0 is 0. So this is 0 minus 5. And this is going to be minus 5. So this answer here is minus 5. Right? Next thing we're going to do, we need to figure out this value here in the table. So you're going to substitute 2 into the equation. So this is going to be y is equal to 2 squared minus 2 minus 5. Right? 2 2s are 4 minus 2 minus 5. 4 minus 2 is 2. 2 minus 5 is minus 3. So this here is going to be minus 3. So you're going to do the same for the next 2 values. Right? So you're going to substitute 3. So this is going to be y is equal to 3 squared minus 3 minus 5. So 3 3s are 9 minus 3 minus 5. 9 minus 3 is 6 minus 5. And you're going to get 1. So this is 1 here. Right? And the last value we need to work out, we need to substitute 4 into the equation. So this is going to be y is equal to 4 squared minus 4 minus 5. 4 4s are 16, minus 4, minus 5, 16 minus 4 is 12, minus 5, and you're going to get 7. So this here is going to be 7, right? So all I've done, I've substituted numbers, right, into the table, right? Now this particular question is not a CXC question, right? But CXC will typically have maybe 2 or 3 values max that you need to work out, and it will only give you a mark for each one, right? A mark for each one. All right, so I have my table now, right? Now, the next thing that they want us to do here, right? Hold on, I just didn't put on back my... Yeah. So the next thing they would want us to do here, on the graph, they want us to... they want to draw the graph. That's what they want us to do, right? So what you need to do, you need to go to your table, right? So the first point that I'm going to plot here is... Hold on, let me do something. Right, so the first point we're going to plot here is this, minus 3 and 7. So you come to the table, you find minus 3 and give me 1 sec, right? Feel I didn't put the correct graph here. Give me a sec, hold on. Yeah, I know your screen black there right now, right? So don't worry about that too much. Hold on. Just give me a sec, right? I'm just trying to get something here for you all quickly. what happened? I had the wrong graph paper on the slide here, right? So it's fixing now. So here's what we want to do. We want to plot this graph. So the first value that I'm going to plot is -3 and 7. So you're going to go to the graph and you're going to plot. So this here is my x-axis and this here is my y-axis. And the first value we're plotting is -3 and 7. So -3 and 7, that's up here. So that's my first point I'm plotting. The next point I'm going to plot this, -2 and 1. So you come back to the graph, -2 and 1 is here, right? So you're plotting that. Next thing we're plotting is this, -1 and -3. So you come across here, -1, -3. This is what I'm plotting here. So we keep going. We have to plot all the data points. So this is 0, -5. So 0, -5 is somewhere here, right? The next point we're going to plot here is 1, -5. So you're going to plot 1, -5. 1, -5 is about here, right? Then we're going to plot 2, -3. So you're plotting 2, -3. So you all realize you're starting to get a quadratic graph. You can see that you're going to get a quadratic graph. Next point you're going to plot is 3, 1. So you come to the graph, you're plotting 3, 1. And then the last point we're going to plot here is 4, 7. Right? So you're plotting 4, 7. So 4, 7 is going to be up here. Right? So the question is saying on the grid, draw the graph, right? And this here is what we call my domain. So your x value is going from -3 to 4. Right? That is important when we are drawing graphs, right? You need to know what is your domain, right? All right, so now we need to, what we're going to do now, we need to draw a smooth curve through these points here, right? You need to draw a smooth curve through these points. So please guys, walk a sharpened pencil in the exam, right? You're going to try to draw a smooth curve passing through all your points, right? Now it's kind of hard for me to do this on using the digital pen here, right? But I'm going to try something, right? So you all going to use your pencil but one thing I don't want you to do in the exam is to take a ruler and join your points. Don't do that, right? You're going to lose marks for that. You need to draw a smooth curve. This is what some students do. They might have points that are doing this, and what they do, they take the ruler and they do this. Take the ruler and they do that. Please do not do that. I am telling you, you're going to lose marks in the exam for that, right? Somebody's asking if quadratics come in, right? They said functions. They didn't specify exactly what, right? So quadratic will come either way, somewhere, right? So either way, you need to learn about that, right? Now CXC only gave you guys broad topics, right? They didn't specify what question is gonna come, right? So we'll see. All right, so that's part 2. The third part, write down the coordinates of the lowest point on your graph. Now, what I've done, I've actually plotted the graph, right? I have a nice smooth graph here, right? And the question says, write down the coordinates of your lowest point on your graph. Now, your lowest point on your graph is what we call our minimum point, right? So if I go to the actual graph here, my minimum point is actually this point here. This fella here is my minimum point. And I need to be able to read off that coordinate of that minimum point. So that minimum point, right, is a coordinate. It's going to have an x value. Now the x value here, if I look at this graph, to me, it looks like about a half, right? Right, that's my x value. That is whatever this value is here, right? And the minimum value looks like about -5.2, right? So you all have to be able to read this off on your graph, right? So you could be asked to read off the minimum point on your quadratic graph, right? So on the graph, on the grid, draw the line of symmetry on the graph. And the next part, write down the equation for this line, right? So here's what a line of symmetry is. You all need to know that a quadratic graph, right, is symmetrical, right, about a vertical line. right? Now what that really means is that if I fold my quadratic along that line, right, the graph is going to line up exactly left to right, right? So let's see how we're doing this. I just want to show you what your axis of symmetry is. So let's make this line a little longer. So your axis of symmetry is simply a line, a vertical line that is going to be your mirror line in your graph, right? So that dashed line that I've drawn there is what we call my axis of symmetry, right? It's a line. If I fold the graph along that line, it's going to line up exactly, right? Now the question says to draw the axis of symmetry. So that's what I've done here. This line here is my axis of symmetry, right? That's my axis of symmetry. The next thing I want you to know is what is the equation of this axis of symmetry. Now your axis of symmetry is always the x coordinate of your minimum point or your maximum point. So my axis of symmetry right is going to be x is equal to whatever the x coordinate of your minimum point is, right? So it's going to be a half. The equation for that axis of symmetry is a half, right? Right? Somebody say my handwriting. Nah, my handwriting real crap foot here because it's kind of hard to write. I mean, I use a digital pen, right? It's a digital pen that I use. It's not a mouse that I'm using to write. All right, so let's see. Moving on to our next question now. We're looking at the different things that CSEC could potentially ask us, right? Now, a lot of the times they can give you a straight line and they can say, here what? Find the equation of the straight line. So like this, determine the equation of this straight line. Now, for a straight line, right, the general form is always this. Y is equal to mx plus c, where m is your gradient and c is your y-intercept. You can find your gradient m of a straight line if they give us a graph by just choosing 2 points on the line. And if I were you, I would choose 2 points that I can easily read off from the graph. So let me get a different color here so we can play around with this. So I can choose this point here because I can read this coordinate. This coordinate here is 2, 3. And let's find the next coordinate that is easy for us to read. Let's say I'm going to use some weird numbers, right, to help you out a little bit here. This coordinate here is -1 and -3. Now guys, to find gradient, you can use any 2 points on the line. It is totally up to you. Right? So CSEC is not going to give you the points. You have to go to the line and read off 2 points on the line, right? Now, the next thing that students don't realize what they need to do, once you select those 2 points, your next step is to label them. So I'm going to label this as x1, y1. I'm going to label this one as x2, y2, right? So step 1, I need to find the gradient of the line. The gradient of the line is given by this formula, which is not given to you in the exam, but you need to know it. y2 minus y1 over x2 minus x1. You all need to learn this formula. Please do so. So, because I've already labeled my coordinates, it's just a matter of substituting into the formula. So, if it's y2 minus y1, it's going to be -3 minus y1 is 3 in this case here, divided by x2 minus x1, which is -1 minus 2. So -3 minus 3 is going to give me -6, divided by -1 minus 2 is going to give me -3. -6 divided by -3 is going to be equal to 2. When you divide two negative numbers, you're going to get a positive number, right? So my gradient is equal to 2 here. Right? Yeah, so somebody's asking about chem. Yeah, something came up and I just couldn't have the chem session yesterday, right? But for any topic in chem, right, you all can go to my chemistry channel, right? If you go to YouTube, I have a chemistry channel. that has most of the material that you all need to know for chemistry. About 90% of the material is there already, right? All right, so I've just worked out the gradient of the line, right? So I have M. You know what M is already. You know this value here. Next thing we need to know what is C. When CXC gives you a graph, you see this point here where it cuts. Remember, this is my y-axis here. Remember, C is always my y-intercept. So this point here is actually my y-intercept. So C is actually, now this is our coordinator. So this here is my y-intercept, right? And it has a coordinate which is 0, -1, right? So the equation of the line that they want here is going to be equal to y is equal to mx, m is 2. So my gradient is 2, x, and my y-intercept is -1. So it's 2x minus 1. That's how we find the equation of a line if they drew it first, right? If they drew it first, yeah. Right, somebody's asking about the slope, right? So the slope, it doesn't matter which 2 points you choose, you're going to get the same answer, right? If everybody chooses different points, you're going to get the same answer for the slope, right? All right, so that's my equation of the line shown, right? Now let's do a next one here. You all need to know about parallel lines and perpendicular lines, right? All right, so CXC can ask us a question like this as well, right? So we have an equation here, and the equation of this line is 2y is equal to 6x minus 1. The first part, determine the equation of a line passing through the point 2 minus 1, right? But it's parallel to the line P. Now, CXC loves to bring questions like this because some students, they just look at the equation and they say, here, what? The gradient of this line is going to be 6, which is wrong, right? What you have to do in a question like this, in all questions like these, you must write it in the form y is equal to mx plus c, right? So this equation, this here is not in the form y equal mx plus c. What you have here is 2y is equal to 6x minus 1. Now, I need to get rid of this 2 in front of the y. In order to do that, I need to divide every single term by 2. So this is going to be 6x divided by 2 is going to give me 3x. And then 1 divided by 2 is going to give me a half. So this here is my equation, right, for the line P. Right, that's my equation for line P. And from this equation here, my gradient is 3 and my y-intercept is minus a half, right? Now, here's what the question is saying. So we're doing part E. So you have a line P, and the line P, let's say this is the line P here, right? And you want to find the equation of a line passing through the point 2 minus 1. So let's say we have some point here, right? I'm just putting this as a label, right? And this point is 2 minus 1. And I want to find a line. So let's use a different color to show you what I'm actually doing here. So you want to find a line, the equation of a line that passes through the point A, but is parallel to P, right? Now, the equation of the line P is this. Y is equal to 3x minus a half, right? That's the equation of the line P. And what the question is asking me to find is what is the equation of this line here. They want to know what is the equation of that line. So here's what's happening. You all need to remember that parallel lines have the same gradient, right? Parallel lines have the same gradient. That's something you need to know. Right? So let's see. Where am I? Right. So we know. Right. So let's call this green line. Let's give it a name. Right. Let's call it Q. I'm just calling it Q, so it'll be easier for me to explain this. So the gradient, right, of P is equal to 3. We know that. The gradient of the line Q has to be equal to that same gradient because they are parallel lines, right? Now, we also know that this line Q here, it passes through this point, which is 2 minus 1, right? So here's what we're going to do. We know that the equation of Q must look like this. Y is equal to 3x plus C. And what we really need to do, we need to figure out what C is. In order to do that, I'm going to have to use a point A in order to do that. So when x is equal to 2, y is equal to minus 1. So I'm going to substitute. I'm going to say minus 1 is equal to 3 multiplied by 2 plus c. So therefore 6 plus c is equal to minus 1. So c is equal to minus 1 minus 6. So therefore c is equal to minus 7. So c is equal to minus 7. So therefore the equation for the line Q, right, is going to be y is equal to 3x minus 7, right? Now these are things you can get in the exam, guys, right? All right, somebody's trying to interfere with the chat there, so I just remove them for a little bit, right? Right, so that's my equation there. So this is one way you can get a question like this, right? Now, what about the part B now? Part B of this question here. So I want to find the equation of a line passing through the point B. So let's do the same thing again. You're going to draw the line P. I want you to visually understand what's happening, you see. And this equation here is y equal 3x minus a half. This here is y is equal to 3x minus a half, right? That's that equation here. Then you have a point here, right? Which in the question I call it B, which is minus 3, 2. So this point here is the point B, and it's minus 3, 2, right? And they told us that this line, it passes through B, but it's perpendicular to the line P. So let's call this line R to help us, right? And P and R are perpendicular, right? So here there's some things that we need to know. So first things first, we know that the gradient of the line P is equal to 3. Right? That's from this here. This number here is telling me that the gradient is 3. The gradient of R, right, is equal to, could you all tell me what is the gradient of R? All right, so here's what you all need to know when it comes to gradients and perpendicular lines, right? Now, perpendicular lines, right? So if I have, this is something you all need to know. If I have a line here and I have a line here, and those two lines are perpendicular, right? So let's say I'm calling this L1 and this is L2, and the gradient of this is M1 and the gradient of this line is M2. For perpendicular lines, M1 multiplied by M2 is equal to minus 1. This is something you all need to know. When you have two lines that are perpendicular and you multiply their gradients, it's going to be minus 1. So if you know the gradient of P is 3, here's what you need to remember. That number 3, you're going to invert it, so it becomes 1 over 3, and we need to put a minus sign in front of it. So the gradient of R is actually going to be minus 1/3, right? So the gradient of R is minus 1/3, right? It's not minus 3, it's minus 1/3, right? So the product of lines which are perpendicular, right, is equal to minus 1. Right? So that's it. I know the gradient of R now. What do I do? So if I know the gradient of R, the equation of R should look something like this. Minus 1/3 x plus c. That's what the equation is supposed to look like. Now the thing is, I haven't figured out what c is yet. In order to figure out c, I need to use this point here, because the point B lies on that line. So therefore, what I'm going to do, so I'm going to say when x is equal to minus 3, y is equal to 2. So I'm going to use that information to figure out what c is. So this is going to be 2 is equal to minus 1/3 multiplied by minus 3, right, plus c. So 2 is equal to minus 1/3 multiplied by minus 3 is going to give me 1 plus c, right? So therefore I can write this as 1 plus c is equal to 2. So therefore c is equal to 2 minus 1. So therefore c is equal to 1. So therefore the equation of R, which is what we're trying to find, is going to be equal to, it's y is equal to minus 1/3 x, right, plus c. So this is plus 1, right? That's my equation for R. Right? So somebody, yeah, so the key thing here, guys, is to remember that when we have perpendicular lines, the product has to be minus 1. So somebody's asking, how did I get 1/3 again? The only way that these two lines could be perpendicular, now you already know that equation of the gradient of P is 3. So therefore, 3 multiplied by what number? 3 multiplied by what number is going to give me minus 1? The only thing that will give me that is if this box here is actually minus 1/3. That's the only way I'm going to get minus 1. Right? So guys, if you want more examples on this, just go to my channel, go to the Tim CSEC Maths channel, right? There are tons of videos. Like I said, I did not recently start posting videos. I've been posting videos for more than 5 years now, right? I just took a break, but I have tons of videos online, right, that can help you guys, right? So those of you who have not done so as yet, please hit like and subscribe, right? And just as a reminder, just as a reminder, I do give online maths, maths, physics and chemistry classes, right? And I can be reached at this number here via WhatsApp, right? Now those of you writing exam next week, please don't try to contact me asking about classes, right? My classes ended at the end of May, right? So I know some of my students are in the class right now, so we ended at the end of May. That was to give my students chance or enough time to be able to revise for the exam, right? So don't message me and say, sir, I want to join your class, right? That Form 5 class has ended, right? My new classes start in August, and that is for students entering Form 4 or those students who plan to repeat, right? All right. Now, the next thing that we need to be able to do, guys, we need to talk a little bit about linear programming, right? Now, I'm not going to go into all the details about linear programming, right? If you go to my, if you don't know how to find the videos, just send me a message and I could show you send you the link to the video, right? But I do have linear programming on my, on this channel, right? Now, here's a question here. We have the region R is bounded by 3 lines. Write down 3 inequalities which define that particular region R, right? Now, I know right now, in terms of all the students here, some of you all may be good at maths, some of you all not so good at maths. But let me ask you all something. What are the three inequalities to define this region here? This region here we're talking about, right? This is linear programming, right? What are my three inequalities here, guys? Let's see if you all can figure that out for me. Somebody's asking about advanced session. I highly doubt it, right? Right, so for linear programming, they could ask you to draw the graph, or they could give you the graph and ask you for the inequalities, right? This can come both ways. Now, I've seen some answers coming in here, but you're kind of on the right track, but nobody has the correct answers yet, right? Daniel Brown, you are on the right track. Xavier, you're on the right track. So here's the problem with some of the answers you all giving me, right? You all giving me equations. We want inequalities, right? We want inequalities. So let's see. King Coda, you're looking like you're giving me the correct answer here. All right, so let me tell you what the answer is, right? So you want to shade that common region R here, right? Before you can even shade anything, you need to know the equations of certain lines. So this here, this line here, right? You need to know this line here because that's one side of the region R, right? So therefore you need to know this vertical line here. In maths, when you have a vertical line, the equation is always of the form x equal to something. In this case here, it's passing through the point 2. So this equation is x is equal to 2, right? That's what that is. Then you have another line here, right? So that line here, that's a horizontal line. All horizontal lines have an equation of the form y is equal to something. Y is equal to, it's passing through this point 5. So this here is the line y is equal to 5, right? Now, the next line that bounds the region R is this line here, right? If you look carefully, right, this is a line that you guys need to know, by the way. Look, this point is on the line, and that point is 1, 1. This point here is on the line, and this point is 2, 2, right? This point here is also on the line. It's a point 3, 3, right? Anytime your x value and the y value are the same, the equation of that particular line here is y is equal to x, right? So there's no calculation to be done or anything like that, right? There are no calculations to be done, right? So that's your first step. Your first step is to come up with equations. That's it, right? That's your first step. Now, that's not the answer, right? That's not the answer. You want to shade a region. So here's what the inequality is going to look like, right? So they said, look at the word there, inequalities, not equations. So here's my first inequality. If you're looking at this line here, the line x equal to 2, that region R actually lies to the right-hand side. So if it's on the right-hand side, that inequality is actually x is greater than or equal to 2. Now, when you guys do linear programming, you need to know when we have to use, if you have a solid line, right, the inequality is going to look like this. Is either x greater than or equal to, or either x less than or equal to. If you see a dash line a line that looks like this, then the inequality could either be x greater than or x less than. Notice the difference between the two. The signs, this here, you have greater than or equal to, but this one here, you just have greater than. All the lines that I've drawn here for this particular inequality or this graph, right, they've all been solid lines. So all my inequalities will be either greater than or equal to or less than or equal to, right? So first things first, you knew this equation is x equal to 2. I need to shade, I'm shading to the right hand side. So my inequality, my first inequality is going to be x is greater than or equal to 2, right? Right? So it's a solid line when it's equal to. All the lines they've given us here were solid lines. Now, the next thing we need to do now, we need to look at, let's look at this line here, the line y equal to 5. If I want to shade the correct region R, I need to shade below that line, right? So therefore my inequality, my second inequality is going to be y is less than or equal to 5. That's my second inequality. Now, to figure out the third inequality now, the next line that we're looking at is this line y is equal to x. But if I want to shade the region R, I need to shade above the line, right? I need to shade above the line, right? Now, if you want to shade above the line, right, that means that y has to be greater than or equal to x, right? That's my third inequality that I'm looking at, right? Right, so I see Chris Ann Holder is asking a question here. Now, the thing is, linear programming is a reasonably long topic, right? And what they can do, they can give you inequalities and ask you to draw the lines and shade the correct region. That's one way they can do that, right? The other way is they can give you the diagram, so it's already shaded, right? And you have to come up with inequalities. Because of how your exam comes now, right? The question that they can bring on linear programming cannot be a very long question. It has to be a short question, and they will help you out a lot in the question, right? Let's see, somebody's asking the second one, y is less than 5. So earlier, right, if this one here, y is less than or equal to 5, this is where the line y is equal to 5 is, right? But if I want to shade, remember this here is my region R we're talking about here. Right, that's my region R. So I want to shade below this line. So if you want below the line, it has to be y is less than or equal to 5. That's all. It's below the line, so it has to be less than 5. Right, somebody's asking, so if you get below the line, yeah, that's correct. That's correct, Asha Smith, right? It'll be y is less than or equal to x if we were to shade below that line. Right? So like I said, I'm trying to cover a range of different questions, right? Because this may potentially be my last session. It depends on if I get some more time. Now I'm going to make a jump here now, right? You all have to be able to solve triangles. They said that's coming, but hold on a sec. Let me let's do this one first, right? Now, CSEC says you all have to be able to solve triangles in the exam, right? Now, you all need to know that we have different kinds of triangles. We have right angle triangles, and we have triangles which are not right angle triangles. Now, I'm not going to go through all the different rules, like sine is opposite over adjacent, Sine is opposite of hypotenuse, right? That's SOHCAHTOA, right? I'm not going to go through all of that. I have a complete video explaining when to use what, right? So just go to the channel. The video is there, right? So let's see if I can work this question here for you guys. So you have a triangle ABC, right? So this is A, B, and C. And they give us some information. So they said, they gave us two 90 degrees, AC, BC, and CD. And they want us to calculate the length of the line DB. So where is DB? DB is this line here, from here to here. Anytime you have a right angle triangle, right? If you have a right angle triangle and you don't have any angles, but you have lengths, right? I definitely have to use Pythagoras' theorem. That's what I need to use. So the only time you're going to use Pythagoras' theorem, you must have lengths. You must have at least two lengths. It must be a right angle triangle, right? So in this particular case, that holds true, right? Look, you have a right angle triangle here. This is 90 degrees. And I have this length, and I have this length here, right? Now, Pythagoras' theorem, yes, they do give you the formula in the exam, but make sure you know how to use the formula. The side that is opposite your 90 degree is always your hypotenuse, right? Which is the longest side of the triangle. So here's what we're going to do. We can say that this side squared plus this side squared is equal to this squared. Sometimes you see Pythagoras' theorem written like this. C squared is equal to A squared plus B squared, right? So it's always the hypotenuse squared. So what I'm going to do, I'm going to say 12 squared plus, hypotenuse squared is equal to 7 squared plus this side here squared, which we don't know. We're trying to figure that out. So it's DB squared, right? Now I could write over that and say 7 squared plus DB squared is equal to 12 squared. Now 7 sevens are 49 plus DB squared is equal to 12 12s are 144, right? So I don't have enough space, so let me just go across here. So DB squared is equal to 144 minus 49. So DB squared, right? So use your calculator to work that out. 144 minus 49, I'm going to get 95. So therefore DB is simply equal to the square root of 95. So DB is equal to 9.7 centimeters. So this here is 9.7 centimeters, right? Right, so I saw some of y'all work it out. Great job, guys. Right, so you can put 9.7 or you can put 9.75. That's fine. I'm not sure how to pronounce this guy's name. Means. Yes, they can ask you that concerning linear programming. They can ask you to find maximum profit or minimize cost, right, in linear programming. Yes, they can ask you that. So what I've done here, I've worked out the length dB. The next part here, they said using trigonometry, calculate the angle CAD. So CAD is this angle here, right? Let's call that theta. What am I going to use to find theta? Am I going to use sine, cosine, or tan? Alright, so I've seen people saying sine, right? People saying sine. So, what I need you all to remember is this. You all need to remember SOHCAHTOA, right? Sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, and tan is opposite of adjacent, right? Now, some of you all have problems figuring out what is the opposite, what is the adjacent, what is the hypotenuse. Now, I'm looking at triangle ACD. That's the right angle triangle I'm looking at. This side here, which is opposite the 90 degrees, is my hypotenuse. Your side opposite the hypotenuse, opposite the right angle is always the hypotenuse. Now, you have this angle theta here. The side opposite theta is called my opposite. And therefore, what I'm left with is called my adjacent. So that's how we label the triangle to figure out what to use, right? So therefore, if I look at this triangle ADC, I have my hypotenuse, I have my opposite, and I want to find the angle. So the only ratio I can use here is sine. So I can say sine. So the first thing you do is to write down the formula. Sine is opposite over hypotenuse. So therefore sine theta is equal to opposite, which is 7. So 7 over 13, right? So therefore theta is equal to arc sine 7 over 13. Right? Let me show you how to do this in the calculator. Right, so here's what you're doing. You're pressing second function on your calculator, sine, right? Open brackets, 7 over 13. Close brackets, equal. And my answer is about 32.6 degrees, right? So my answer here is 32.6 degrees. Now, some students, they can work it like this. Some of you all can't, right? What you could do, one second. What you could do is do this. You work out the 7 over 13 first. 7 divided by 13. I'm going to get this big long decimal. And then all you do, you press second function, sine, and you're going to get the same answer, right? So however you want to work it out, that's fine. But the answer is 32.6 degrees. All right, so that's just one question here. I have a next one. So this one here, we have two triangles joined together, and here's what I want. They told us that AB is 3 meters, that's this length here. They told us that AC is 5 meters, that's this length here. And they gave us an angle of 45 degrees, right? They gave us an angle of 45 degrees, right? What am I doing? Right. So I want to get the length. They said they want the length BC, calculate the length BC, and show that it rounds to 3.58. Now, anytime in the exam you get a question where they say show something, that's a nice question because you know what the answer is already. You're not fighting up to figure it out. That's the answer. Now, if we look at these triangles here, at no point did they tell us that we have a right angle triangle. Whenever they give you something like this, it means that I can't use this. I can't use so, ka, toa. I've seen students, as soon as they see a triangle, they feel they can use this for any triangle. That is wrong, right? You can't use that for any and every triangle, right? What you need to do, you need to either use your sine rule or your cosine rule. That's what we have to use. Sine rule or the cosine rule. Now, let's see. So we have something called the sine rule. I also have a video on this. You can check that out. You have the sine rule and you have the cosine rule, right? Now, I use the cosine rule if they gave me all 3 sides and no angles. That's when I could use the cosine rule. That's one scenario. The second scenario of using the cosine rule, they must give me 2 sides and the angle between those 2 sides, right? But if we look at this scenario here, they want us to work out the length BC. That is this length here, right? And look, I have two sides and I have the angle between the two sides. Therefore, I must use the cosine rule. Now, in the exam, you will be given the cosine rule, right? And they're going to give you it looking like this. C squared is equal to A squared plus B squared minus 2AB cos C. So they will give you this formula in the exam, but some students don't know how to use the formula. So when you're using the cosine rule, because I'm going to use the cosine rule to answer this question, the side opposite my angle is actually my first term here, right? So C, right, C squared is going to be this length here, BC. So this is going to be BC squared is equal to A squared. So you can use any one as A. You can either use this as A or use this as A, right? So if I use it 3, so it can be 3 squared plus 5 squared minus, put this in a bracket. It's going to be 2 by A. Look, this is A here. This is 3. So 2 by 3 multiplied by this figure here, which is 5, multiplied by cos of the angle between the two sides we know, which is 45 degrees. So this here is 45 degrees. So all I've done is substituted into the formula. That's all I did. Now, even with this, students have trouble because they try to do it in one go in the calculator, right? Please don't do that. Work it out in parts. 3 squared will give me 9, plus 5 squared is 25, minus. So this part here, I will use my calculator. So this part here is going to be 2 multiplied by 3 multiplied by 5 multiplied by cos 45 equal 21. So put this about 21.21, right? Put this at about 21.21. So this here is 21.21. So therefore, B squared is equal to, so again, I'm using my calculator to do this. So this is going to be 9 plus 25 plus 21.21, and I'm going to get 55.21. So this here is 55.21. So therefore, BC is equal to the square root of 55.21. So BC is equal to second function square root equal, and I'm going to get 7.43, right? But something looking wrong here though. Did I make a mistake somewhere? Hold on. Calculate the length BC, because they're saying that BC is 3.58. Let me just make sure I didn't make a mistake. So that's 3 squared. Hold on. Alright, so I have a mistake somewhere here. 3 squares, that's 9, 5 is 25. 2 by 3 by 5 by... Okay, so I don't know what I did here, but I made a mistake here. Hold on. So let's just do it for that calculation in the calculator there, right? I have an error. I never typed something wrong in the calculator. So this is, all right, so let's do over this. 9 plus 25, right, 34, minus 21.21. I feel I added it just now. So this is 12.79. Right, this is 12.79. Right, so BC squared is that. So BC is the square root of 12.79. So let's double check that answer here. So second function square root, right, and I'm getting 3. If you round it off, it'll be 3.58, which is what they asked for. So this here is 3.58. and this is meters. And look, this is what they said to prove, right? Right, so you all need to know when we can use the cosine rule, right? So there are only two conditions where we use the cosine rule. We must be given all sides and no angles, or we can be given two sides and the angle between those two sides, right? So that's part one. That's what we did here. The next thing they want the angle BCA. Where is BCA now? BCA. They want this angle here, right? They want that angle there. So we just worked out this length here. So let us put it on the diagram because that helps us sometimes. 3.58 meters. How am I going to find BCA? All right, let's see. So you're all saying use the sine rule, right? Use the sine rule. So there are certain conditions under which we use the sine rule, right? We only use the sine rule when we have two sides and two angles. Sorry, two sides, one angle, or two angles on one side, right? That's when we use the sine rule. So let me just draw a quick sketch here so we can see exactly what we're doing, right? So this is what we have. A, B, C. So this is A, this is B, this is C, this is the angle that we want. This here is 45, right? What were the sides again? 3, 5. So this was 3, this was 5, and this was 3.58. Right? And we want to get this angle here. So yes, we have to use the sine rule. The sine rule formula is given to you in the exam, right? So the formula looks like this. It can be A over sine A is equal to B over sine B, right? Now I typically try not to let my students learn off the equation. You need to understand what you're doing. You want to get this angle here, right? So the side of interest to us is this side here, which is the 3. You have the angle 45, so the side of interest to us is that 3.58. So it's a side divided by sine of the angle opposite that side. So let's say we're using the 3 meters. So it's going to be 3 over sine angle, what they call it in question, angle BCA. BCA, that's the angle we're talking about, right? Is equal to, and we're going to put 3.58 divided by sine of the angle opposite, which is 45 degrees. So the sine rule is much easier to use than the cosine rule, guys, right? So in the sine rule, to solve, what we typically do, we have to cross multiply. So this is going to be 3.58 multiplied by sine BCA, which is equal to 3 multiplied by sine 45 degrees. So therefore sine BCA is equal to 3 multiplied by sine 45 degrees over 3.58. So therefore sine BCA, right? So let's work that out there. So that's, I'm going to use my calculator because I'm making mistakes with the online one here. So 3 multiplied by sine 45 divided by 3.58. And what I'm getting here is 0.593. So therefore angle BCA is going to be arc sine of 0.593. So therefore BCA is going to be about 36.3 degrees. Alright, so some of you all got the answer there. Good. Alright, this is some of your accent. So just remember, you only time, right? So let me just make sure you all have this clear in your head, right? That's all. So here it is. So if I have a right angle triangle, right? If I have a right angle triangle, this is what we could use, right? We can use we can use Pythagoras' theorem. Right? If it's a right angle triangle, we can use Pythagoras' theorem, right? We can use sine, right? Cosine and tangent, right? Those are the actual names for these things. Huh? So this is where we're going to use right? So please don't just, when you see a triangle, say you could use this all the time. That's not true. Has to be a right angle triangle. Now, if the triangle is any other kind of triangle now, let's say the triangle looks like this, right? So this one is a right angle, right? This one is not a right angle, right? Then I have to use the sine rule, right? Or the cosine rule, right? But there are conditions under which we use these things. So you use the sine rule when you have two angles, right? And one side, or you have two sides and one angle, right? That's how we know if you are using the sine rule. In the case of the cosine rule, right, you must have three sides, no angles, right? And the second condition under which we use the cosine rule, you have two sides, right, and the angle between those two sides, right? So if you all never knew what the conditions were, these are the conditions, right? Alright, so somebody's asking if I have, yes, I do have videos on transformation geometry. So I have videos on reflection, rotation, all of those things are on the channel, right? There are tons of materials there, right? Right, so Vikash is saying if these things apply to bearings, yes. If you do get a question on bearings, which I don't think you are going to get one, that's just me, right? I don't personally think you're going to get a question on bearings, right? But if you do, definitely you're going to have to use the sine rule and the cosine rule. But CSEC says you have to be able to solve triangles. So they could just give you some triangles just like what I'm giving you here, and you are expected to know when to use the sine rule, cosine rule, or sine, cosine, and tan, right? Now the thing is, they gave you guidance. They didn't say that is what coming, right? It's just guidance. So we could only make a guess as to what we can see in the exam, right? All right, so I wanted, now in the exam, you all are going to get what we call an investigation question, right? Now, one of the things that you all need to be familiar with, right, is your syllabus, right? You know you're going to have 10 questions in the exam. All 10 questions are compulsory, right? Let's see what you all saying here. Linear programming might come. No, linear programming is coming. CXC says so. Cumulative frequency, I have it on my channel. Yes, we did it last week or week before as well as one of these sessions, right? There will not be any question on sets. Sets is not in the paper 2 at all. Sets comes in the multiple choice, right? Yeah, so what I was saying is that one of the questions that you are getting in the exam for sure is what we call an investigation question, right? It's an investigation question. It is worth usually anywhere between, could be up to 9 marks in the exam, right? And what they do in the exam, they give you some diagrams in most instances, and you have to identify patterns, right? So the question that I'm going to look at here is the one that came in the January 2021 paper, right? I'm going to look at the question that came in the January 2021 paper, right? So this is one of the investigation type questions. So the diagrams below show a sequence of figures, right, made up of circles with dots. Each figure has 1 dot in the center and 4 dots on the circumference, right, of each circle. The radius of the first circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle, except for the first figure. A portion of each of the figures is shaded. So they're just talking there, right? But they've given you some diagrams, and you have those are what we call concentric circles, right? So you have 4 figures here: figure 1, figure 2, figure 3, figure 4, right? Now, usually when they give you an investigation question, there's a table inside here. So if we go to the actual question now, so look, this investigation question came for, that's 437, actually it's more than that, right? But this is the table that they have here. So they have, in the first column, you have the figure number. So the figure number is actually what's here. This is figure 1, figure 2, figure 3, figure 4, right? Now, the next part, they said number of dots. Now, in the first figure, they're saying that we have 5 dots. First of all, let's make sure we understand how they get 5 dots. So let's go to the first figure. If you look, you have a dot here, 1, 2, 3, 4, 5. So you have 5 dots. That's how they got the number 5 from. Now, the next part here, they have area of the outer largest circle. Now, let's go back here. The area of a circle is actually pi r squared, right? So in the table, we have area of the largest circle. So in this here, the first circle, my area is pi r squared. But if you read what they said here, they said the radius of the first circle, look, the radius of the first circle is 1 unit. So it's pi by 1 squared. So therefore, 1 squared is 1. So my area is pi. So look, that's where they got this pi from, right? Area of the shaded region. In the first figure, you shaded the whole circle. So therefore, that area has to be pi as well. So look, this is pi, right? And the last column, they said total length of the circumference of all the circles, right? Of all the circles. Now, in this first figure here, you only have 1 circle. Circumference of a circle is given by 2 pi r. So therefore, the circumference for this first circle here is going to be 2 pi multiplied by my radius, which is 1. So this works out to 2 pi. So look, that's where they got 2 pi from. So you need to understand your diagram, and you need to understand how they come up with stuff in the table, right? Let's see. Right, so Bikash is asking if I can use the ADMATS method. It depends on what the question is, right? We don't know the pattern as yet, right? But I know what you're asking for. If it's an arithmetic progression, that's the formula you're giving me there, right? So let's try. So what you need to do for these questions, right? So no teacher could actually teach you how to do the questions. We can practice a ton of questions and then you kind of get an idea as to how to answer these questions. So in the second figure, right, let's try to understand the second figure. Make sure we understand how to get the numbers, because you need to understand how they get to the numbers, right? In the second figure, look, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 dots in your second figure. Well, look at that. That's how they get 9 dots. Now, notice what I said, right? The area of the outer or the largest circle. So let's go here. For this figure 2 here, my area for this, the bigger circle, right, is going to be pi r squared. But look at the radius of the big circle is going to be 2, right? Because if each one of these lines here represent 1 unit, the radius is going to be 2. So it's pi multiplied by 2 squared. So this should be 4 pi. So that's how they got 4 pi. That's how they got this, right? Now, in this next column here, area of the shaded region, right? Now the shaded region, if you look at this, to get that shaded region is the area of the whole circle minus this white piece in the middle here. So that is actually, so that area of the shaded region is going to be 4 pi minus the area of the white circle, which we already knew that's supposed to be pi. So this here is going to be 3 pi, right? Let's see if they got that in the table. Yes, that's what they got here, 3 pi. And the total length of the circumference of all the circles, now let's see that part now. So in figure 2, you have 2 circles. So you have this circumference here, and then you have this bigger one here, right? So the small circumference, so C1, remember this is the formula we're using here, 2 pi r. So it's 2 by pi by 1, so that's 2 pi, right? The second circle, the bigger circle, is going to be 2 pi multiplied by 2, which is going to give me 4 pi, right? But they're telling us here what? We need to add the 2 numbers here, right? The total circumference. So let's see if they have 6 pi. Yes, they do. They have 6 pi. So these questions require a lot of thinking, guys, right? You have to think. You need to, that's why they call it an investigation question, right? Now, here's what they want here. They want us to complete this line. This is part 1, right? But you have to look for a pattern. You're looking for a pattern. That's what you're looking for. When I go from 5 to 9, right? From figure 1 to figure 2, I am adding 4. When I go from here to here, I am adding an x 4, right? 9 and 4 is 13. When I go from here to here, I'm adding an x 4. So therefore, tell me what is supposed to come in this first, in this cell here. What number am I supposed to put there? Alright, I've seen some of you all saying 21. That's talking about right to me. All you're doing here, you realize you keep adding 4, right? So therefore, to go from here to here, we're just going to add 4. So 17 plus 4 is going to be 21. So this is 21, right? Now, let's see what's happening. So we need to figure out this here, what's happening here now. So what we're doing here, you're going from pi to 3 pi, right? What you've done there, you've increased by 2 pi. So what we're doing here is adding 2 pi. When you go from here to here, you're adding 2 pi again, right? Because 3 pi plus 2 pi is giving me 5 pi. When I move here, I'm adding 2 pi again. 5 pi plus 2 pi is going to give me 7 pi. So what am I going to put here then? right, so you all say 9 pi, that's sounding right to me. So you're going to add an extra 2 pi here. So therefore this here is going to be 9 pi. So most of these questions here, you have to look and figure out the pattern, right? Now let's see what happened with this one here now. So the numbers are increasing. You're going 2, 6, 12, 20. So from here to here, now we're just trying to figure out if there's a pattern, right? So 2 pi, we increase them by 4 pi. Then you increase by, how much is this here? 6 pi, right? Then you increase by 8 pi, right? What am I going to get as my answer there? All right, I see you all saying 30 pi. That's true. That's correct. It is 30 pi. Because if you notice here, you started off with a difference of 4 pi. Then you had a difference of 6 pi. Then you go 8 pi. So therefore my difference here should be 10 pi. So therefore 20 pi plus 10 pi is going to give me 30 pi. So that's it. That's it for 3 marks there for filling out these things. So what you have to do, you have to look and identify what is the pattern. That's what we're doing. Right? We're looking and trying to identify a pattern, right? So that's 3 marks. Now let's do this part here now. So now they, instead of giving us numbers now, they give us an n, right? So what you are trying to do now, you are trying to find a relationship between my figure number and whichever column that we're looking at. So if you look at this column here, I'm sorry, this row, right? You're trying to find a relationship between this 1 and this 5 here. A relationship between this 2 and this 9 here. You all think you can see, tell me what relationship I'm going to put there? Right, so yeah, the live is always going to be saved, right? I see you all saying 4n plus 1, right? That's correct. So here's what helps you, right? You know the difference is 4 here. Each one here, it's a constant difference of 4, right? But there's a relationship between my figure number, that's this column here, and this column here, right? If I use this 4n plus 1, now we have to check it to make sure it's true, eh? So if I plug in 1 into this formula here, that's 4 by 1 plus 1. So that's 5. So that's correct. Then 4 2s are 8 and 1. That's 9. That's correct. If I plug 3 into that formula, 4 3s are 12 and 1, 13. That's correct. 4 4s are 16 and 1, 17. That's correct. So therefore, this is correct. This equation is correct. We need to figure out this equation here. What is the relationship between my figure number and the area of the outer largest circle? What am I putting there? So I see you all saying n squared pi. Let's see if that's correct. N squared pi. Yeah, now looking correct to me. This should be n squared pi. That's correct, right? Because look, if you look at this column and this column here, if I square 1, right, and I multiply by pi, I'm going to get pi. 2 squared is 4, so 4 pi. 3 squared, 9 pi. 4 squared, 16 pi. So that's correct. It's n squared pi. What about this one here now? So as you all realize, there's no fixed formula that I can give you. You have to recognize the pattern, right? That's why it's called an investigation question. Now in some of these here, you're going to have to play around with some numbers, right? You got to play around with some numbers, right? So if I were to look at this pattern here, right? And I'm trying to find a relationship between the first column and this column here. That's what I'm trying to do, right? So you have 1 and then you have pi, you have 2 and 3 pi. So if I look at those numbers, my relationship could be something like this. 2n minus 1 multiplied by pi, right? 2n minus 1 multiplied by pi. Now, I think I saw Vikash asking if you can use the formula. Yes, you can use the formula because in this particular question here, they don't give you enough space to write down all you're working for it, right? So once you put the correct thing, it doesn't matter what you use to work it out. Whether you use the AddMaths formula, right? Or you use, just by reasoning it out, you can do that if you want, right? So the relationship there is 2n minus 1 multiplied by pi, right? What about the last one? What about this last relationship here? Alright, so I'm seeing some answers coming in here. Let's see. Alright, so you're finding a relationship between this column, your first column, and your last column, right? So if we look at the numbers, figure number, you have 1, you have 2 pi, then you have figure 2, and they have 6 pi, then you have 3 and 12 pi, right? So we're trying to find a relationship between these two here. That's what you're trying to do. So figure 4, you have 20 pi, and then figure 5, you have 30 pi, right? Now if I look at these numbers here, right, it's increasing, right? From here to here, you're going by 4 pi, then you go 6 pi, 8 pi. So it's increasing, but it's not increasing by a fixed amount. So I know that I'm going to have like a square or something inside of it, right? But what's something here? If you multiply n by n plus 1 multiplied by pi, hold on, multiply by pi, this relationship here will work, right? If you try that, that's going to work. So what we're saying is that figure number, let's say figure number 1 plus the figure number right after, so figure 1 and figure 2. So if you take these two numbers here and you multiply them, you're going to get 2. If I take these two numbers here and I multiply them, I'm going to get 6. These two numbers here and I multiply them, I'm going to get 12. these two numbers, when I multiply them, I'm going to get 20. So if you take the figure number, your current figure number, multiply by the figure right after, and you multiply by pi, you're going to get that answer. So this is going to be n multiplied by n plus 1 multiplied by pi, right? So 4 marks for this here. So like I said, I can't teach you how to do this. The only way you're going to be able to do this is by practicing a good bit of questions, right? For sure, you're going to get an investigation question, right? One of your questions in the exam will definitely be an investigation question. And the question still have more parts too, right? Still has more parts. So this part here, determine the value of n when the number of dots in figure n is 541. Now, remember from the table, the first column was number of dots, and you have a formula. It's 4n plus 1. So therefore, 4n plus 1 is equal to 541 dots. So we just need to solve for n here. So 4n is equal to 541 minus 1. So 4n is equal to 540. So therefore n is going to be equal to 540 over 4, right? And therefore n, right? So 540 divided by 4, you're going to get 135, right? So this here is 135. So that's figure number 135, right? Right? Unfortunately, I won't have enough time to do a next question, right? I did about 6 or 7 of these, or probably more, in my live classes, right? I think this is the only question I didn't do for them in class. Right? So the figure number is 135, right? And then the last part now, write down in terms of p and pi, the largest circle in figure 3p. The largest circle in figure 3p, right? So the largest circle in figure 3p. Right? So they want the area of the largest circle. So if your figure is figure 3p, it means that n is equal to 3p, right? And largest area, right? Right, so that's this column here. That's the n squared pi, right? That's n squared pi here we're looking at, right? So all we need to do, the area of the largest circle, so area of largest circle, right, is equal to, according to the formula, is n squared pi. That's this formula here. Right, so this is n squared pi, right? But n in this case is 3p. So it's 3p squared multiplied by pi. So you all need to know how to square this. So you have to square everything inside the bracket. So this is going to be 9p squared pi, right? 9p squared pi. So that's my answer there for part C. So this one is part B, and this one here is part C. So this is what they got in the January 2021 paper, right? Because the paper that went in January here. All right. So guys, this is all the time that I have available today, right? So I touched on several different things for you all. If I don't get a chance to do any other live sessions, I want to wish you all good luck, right? Take your time in the exam, try your best, answer all the easy questions first, right? The ones that you could do, right? But like I said, if I do get some time, I may do some impromptu lives, right? So just make sure you like the channel and hit subscribe. So whenever I go live, you'll get a message on your phone or your laptop or your whatever you use to watch these classes, right? Somebody's asking, so I heard CXC drastically change up the question, meaning that it requires more think, and also with the paper one, is that true? Right, so CXC was supposed to change the paper one questions because it said everybody has the paper ones, but based on the January 2021 paper, all they did is change up some numbers. They brought a few new questions, and that's about it, right? The paper 2 is no different than any other paper 2 that they've brought since May 2018, because that's the new syllabus, right? So that's it. Somebody's asking what's the name of my class. Well, the name of my website is Terry Learning, right? It's my own e-learning platform, right? All my live classes are done from there, right? So guys, like I said, this is all the time I have for today, but look out, I may during the week, right? We still have some time during the week. If I have a little hour or half an hour, I can do something with you guys, right? So like I said, make sure hit like, hit subscribe, right? My new classes start in August, all right? So guys, afternoon everybody, take care and be safe everyone.